Hi everyone. Today we are going to be covering lesson 5.15 and 5.16, and we're going to be talking about parallelograms. So some things to know about parallelograms. We have 5 very important properties. The first property of a parallelogram is to know that opposite sides are parallel. That's how it gets its name, parallelogram. Another property about a parallelogram is that the opposite sides are also congruent. In a parallelogram, opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. So if I had a picture of a parallelogram, here's a parallelogram. I could put all of these properties in it. See. There we go. Okay, so if I'm going to say the opposite sides are parallel, then I'm going to mark the opposite sides parallel. Remember, that's what these little arrows mean. Okay, so one arrow is parallel to the one arrow, double arrow is parallel to double arrows. It also says the opposite sides are congruent. So this side is congruent to this side, and this side is congruent to this side. Opposite angles are congruent. So this angle is opposite this angle, so they are congruent. And this angle is opposite this angle, so they are congruent. Consecutive angles are supplementary. It's a little bit more challenging to put in my picture. I'm going to label these points A, B, C, D. So what I'm saying here is angle A plus angle B will equal 180. Or I could say that angle B plus angle C, they're consecutive, they're next to each other. Or angle C and angle D. Or angle A and angle D. Those are all pairs of consecutive angles, so they are supplementary. And the last property says the diagonals bisect each other. So here's a diagonal, and here's a diagonal. Bisect means cut each other in half. So this piece will be congruent to this piece, and this piece will be congruent to this piece. They're not necessarily all congruent to each other. It's just that they are bisecting each other, so the diagonals cut each other in half. We're going to use those properties to figure out the missing pieces. So in this example, it's telling us it's a parallelogram. So let's see. AB is 15. I know that in a parallelogram, opposite sides are congruent. So DC is 15. BC is 8. So now I know what AD is. It's 8. I know that in a parallelogram, opposite angles are congruent. So D is opposite angle B. So angle B has to be 68 degrees also. And we know that in a parallelogram, consecutive angles are supplementary. So angle A and 68 have to sum to 180. So if I take 180 minus 68, I get 112. So angle A is 112. A and C are opposite each other. They have to be congruent. And now I can fill in everything I need here. AD is 8. DC is 15. Angle A is 112 degrees. Angle B is 68 degrees, and angle C is 112 degrees. Down here in this example, it tells me this is a parallelogram. So I know the opposite sides are congruent, so I'm just going to go ahead and mark those right away. I know that diagonals bisect each other, okay, cut each other in half. So that means UV and SV are congruent. So SV is 7. There's a very important piece of information here. It says RT is 30. Okay? So this diagonal is being bisected or cut in half. If the whole thing is 30, then each of these halves has to be 15. So now I can say that UT is 27, ST is 18, VS is 7, and VT is 15. Here's another parallelogram. Let's fill in all this missing stuff. Let's see, it says XY is 15, WX is 22, ZX, that's this whole thing, is 52. It's kind of challenging to mark ZX. So instead of marking ZX, what I do is I just mark each piece because I know that ZX is being cut in half. So half of 52 is 26. So this is 26 and that is 26. WT is 23. And before I deal with these angles, let's finish filling in all of our lengths. If WX is 22, the side opposite has to be the same. XY is 15, which means WZ has to be 15. And if WT is 23, then TY has to be the same thing since it's being cut in half. Now let's deal with the angles. Angle WZY is 72. WZY, that's this whole thing, is 72. WXT, that's this one, is 35. So it's just this angle here. And ZWT, that's this angle right here, is 59. All right, let's fill in the sides. ZW is 15. ZY is 22. TX is 23. No, I'm sorry, it's 36. TX. $26. Oh my goodness, I can't read my own handwriting today. There we go. And WY is 46. There we go. Okay. Now let's deal with these angles. I got a lot going on in my picture. I'm going to erase all this green because we just dealt with all the sides. So let's just deal with the angles now. Makes it a little nicer to look at. Okay, we know that in a parallelogram, opposite angles are congruent. So angle WZY, this whole angle, has to be congruent to this entire angle. And if that piece is 35, then I can figure out that other small piece. I can do 72 minus 35 and get 37. So this piece over here has to be 37. Now remember, the opposite sides are parallel, so all properties of parallel lines are still fair game. Alternate interior angles will still be congruent. So if this angle is 37, that means this small angle is 37. And if this angle is 35, then this small angle is 35. Okay. Let's look up here at angle W. This is 59. Alternate interior angle would make this angle over here 59. Okay. Right now in my parallelogram, I have a 72-degree angle right here. I can figure out the measure of that whole angle because these are supplementary. So if I do 180 minus 72, this entire angle is 108. So this whole thing is 108. And this piece is 59. So if I do 108 minus 59, it gives me this little piece up here as 49, which means this little piece here is also 49. Now I have all the angles that I need, I think. TZY. TZY, it's right here, that's 35 degrees. XYZ. XYZ, that's this whole big angle is 108. That's what we said it was. Or you could just do 49 plus 59, get the same thing. XWT. XWT is 49. And XYT. XYT, that's 59. Okay, let's look at number 7. Okay. Here I have a parallelogram, and opposite sides are labeled. We know the relationship between the opposite sides. Opposite sides are congruent. So I can say that LM is congruent to PN. To set this up algebraically, I can say that 9x minus 25 has to equal 5x plus 7. And now I can solve for x. X equals 8. To double check your work, you could plug this in. 9 times 8 minus 25. So LM is 47. 5 times 8 plus 7 is 47. They are indeed equal, so we did this correctly. Number 9. If TV is 74, so this whole thing is 74. It's a diagonal. In a parallelogram, diagonals bisect each other. So I know that each piece of this diagonal is 37. 74 divided by 2. So this is 37, and this is 37. And it says that WV, that's this piece, is 4x plus 1. So I have an expression and a number labeling the same segment, which means that this must be congruent. X equals 9. Okay, so it told me that VW is 4x plus 1, and it told me that the whole length of the diagonal is 74. So this length has to be half of 74, which is 37. So then I can solve for x by making them equal. In number 11 here, in my parallelogram, I have opposite angles labeled. And we know that a property of a parallelogram says that the opposite angles are congruent. So I can say that angle A is congruent to angle C. Or in other words, their measures are equal. And we'll solve for x. So x equals 13. Now it wants to know the measure of angle B, this guy. So what I'm going to do is take my 13, and you can plug it in for either A or C. It doesn't matter. So let's see here. 6 times 13 minus 15 is 63. If you plugged it in up here for C, you would still get 63. So now I have some consecutive angles in a parallelogram. Consecutive angles in a parallelogram are supplementary. So I can say that 63 plus angle B equals 180. Subtract 63 from both sides, and angle B, or the measure of angle B really, is 117 degrees. Let's look over here at example 12. I have another parallelogram, and they're giving me an expression for P and Q. These angles are not congruent. These are consecutive angles in a parallelogram, which means they are supplementary. So I can take their expressions and add them together to get 180. And I can solve for x. So x equals 17. And then I want to find angle R. Well, I know that angle R will be congruent to angle P because they're opposite angles. So I'm going to take my 17 and plug it in here. 3 times 17 plus 5. You get 56. So this angle is 56 degrees, which means that angle R also has to be 56 degrees because opposite angles in a parallelogram are congruent. Okay. Got another example here. All right, we're going to go back to that distance formula that everybody loves so much. We're going to determine whether this is a parallelogram using the distance formula. Okay, the first thing I would do is I would sketch this. You can use a piece of graph paper if you want to, or you can just sketch it. -7, 4. (1, 2). 9, -8. And 1, -6. Sometimes sketching it can reveal things about that shape that you would not have recognized if you hadn't sketched it. This doesn't really reveal a whole lot to me, but sometimes maybe you'll see a horizontal side or a vertical side or something like that that could make it just a little bit easier. I don't have any vertical or horizontal sides in this one, so we're going to use the distance formula. Remember the distance formula, which we have memorized at this point. Here it is. Okay, if it's a parallelogram, it means that its opposite sides are congruent. Okay, so what we're going to do is we're going to find the length of each side. If AB is congruent to DC and BC is congruent to AD, we have a parallelogram. So we are going to find the length of each side. We're going to find the length of AB using the distance formula, the length of DC using the distance formula, the length of AD using the distance formula, and the length of BC using the distance formula. Please do that now. Okay, so you can check your answers with what I have here. Now, I was a little naughty or not good, and I didn't simplify my radicals, but that's okay because it didn't ask me what the distance was. I'm just trying to prove that they're congruent. So I know that the square root of 68 is congruent to the square root of 68. Whether it can be reduced or not doesn't make it any less congruent. So because they are both the square root of 68, I'm allowed to say that AB is congruent to DC. So that's congruent to that. And in AD and BC, I didn't simplify those radicals either, but even if I did, it wouldn't make them any less congruent. So you're welcome to simplify them if you would like, but we're just trying to prove they're congruent. So since they are, I can say that AD is congruent to BC. They're the same length. So then I can write this as a sentence. Yes, ABCD is a parallelogram because its opposite sides are congruent. If I had gotten that they weren't congruent, like if I'd gotten the square root of 68 and the square root of 59, those would not be congruent and I could have stopped right then. Because as soon as the opposite sides, either pair, are not congruent, it can't be a parallelogram. Okay, we're going to do a very similar thing here. Let's sketch the picture and then find the length of the sides. If the opposite sides are congruent, it's a parallelogram. If the opposite sides are not congruent, it is not a parallelogram. So try this one now. Okay, so if you sketched your picture, it looks something like this. It might even look better, probably does. I noticed I don't have any horizontal or vertical lines. And the reason I look for those is because if there's a horizontal line, I can just count the blocks and I don't have to actually use the distance formula. Same with vertical lines. But I didn't have either of those. So I used the distance formula and I started testing PQ and SR. And the length of PQ was the square root of 104. And that can be simplified, I think. But I didn't need to because I just want to see if it's congruent to SR. For SR, I found the square root of 82 to be the length. Well, the square root of 104 and the square root of 82 aren't congruent. Even simplified, they're not. So because those opposite sides aren't congruent, I can stop right there, because as soon as one set of sides aren't congruent, it doesn't even matter about the other sides. So this is not a parallelogram. So that was 5.15. Let's look at 5.16. Okay, 5.16 is also about parallelograms, but it's about two special types of parallelograms. The first type of parallelogram is a rectangle. A rectangle is a parallelogram. A rectangle has every property of a parallelogram and two extra properties. So every property of a parallelogram, so these are all the properties that we wrote down in 5.15, plus all four angles are right angles. And the diagonals are congruent. So not only do the diagonals bisect each other, but the diagonals are also congruent. So if I were to draw a picture of that, okay, this would have every property of a parallelogram. And in addition to those properties, I would have four right angles. And the diagonals are congruent. So this diagonal is the same length as that diagonal, which means that when they bisect each other, these pieces are now all the same length. So let's practice using those properties. So every property of a parallelogram is still fair game, plus the two additional properties for a rectangle. So in this picture, I see that PQ is 24. Okay, so since PQ is 24, that means that SR is 24 because the opposite sides are congruent, just like in a parallelogram. PS is 10, which means that QR is 10. And this right here, don't forget like any additional information. SQ is 26. So this SQ being 26 and it being a rectangle tells me that PR is also 26 because that's the other diagonal. And diagonals bisect each other. So if SQ is 26, then ST has to be 13 and TQ has to be 13. And if PR is 26, then PT is 13 and TR is 13. Now I have everything I need to fill these in. QR is 10, SR is 24, SQ is 26, you told us that. PR is 24 and QT is 13. Let's look over here at number 2. Okay, I know the opposite sides are congruent, that it gets that property from being a parallelogram. I know that the diagonals bisect each other, and the diagonals are congruent because it's a rectangle. So that means that these two pieces also have to be 15. I don't have a way to find BC and AD, but it's not asking me for those, so that's okay. AC is this entire diagonal, the two pieces of 15 together, so that's 30. BD, it has to be congruent to AC, they're diagonals of the same rectangle. BE is 15, and AB is 27. In this picture, it's still a rectangle, same directions as the last slide. It says that DB is 42. So from here to here is 42. Because it has all the properties of a parallelogram, I know that E is bisector or a midpoint of BD. So ED is 21 and BE is 21. AD, that's here, is 26. Opposite sides of a parallelogram are congruent. AB is 33. So So that means this is 33. Oh, the diagonals are congruent. So if BD is 42, then AC is 42, which means each of these small pieces is also 21. DAE is 52. I'll put the angles in a different color. DAE, so this is 52. So now let's look at this kind of broken down. If I look at just this triangle, I see an isosceles triangle. How do I know it's isosceles? These sides are congruent, which means these angles are congruent. So if this is 52, so is the other base angle. Well, if I know two angles in a triangle, I can find the third, because the three angles in a triangle have to add to 180. So I can do 180 minus 52 minus 52, or if you have another way, that's fine too. But this missing angle is 76. Okay, so then let's look at this triangle. Oops. Okay, it's another isosceles triangle, and I actually can figure out my base angle here. Remember, in a rectangle, all of the angles have to be 90. So if this angle is 52, I can figure out this angle by doing 90 minus 52. So this angle is 38 degrees. This is another isosceles triangle, so this has to be 38 degrees. And I could figure out that vertex angle. Or I see a linear pair here, 180 minus 76, so this is 104. Vertical angles are congruent, so this is 104 and this is 76. This angle will have to be 52 and so will this one. And these two angles will have to be 38. Now I have everything I need to answer all these questions over here. AC is 42. It's the length of this entire diagonal. Each piece is 21. EB is 21. BC is 26. AB is 33, and it told us that. Okay, now angle ADC. Here's A, here's D, here's C. That is this angle here, that's 90 degrees. ABD, that's this angle here, that's 38. BCA, that's this angle at 52. And DEC is this angle here at 104. Okay, moving on. I've got some examples here with more rectangles. In this example, opposite sides are labeled. And remember, a rectangle is a parallelogram, which means the opposite sides are congruent. And then we'll just solve for x. It doesn't answer the question. The question says find EF, so I'm going to take that 11 and plug it in for EF. 7 times 11 is 77. 77 minus 39 gives us 38. So the length of EF is 38. Simple enough. In number 7, it says that RT is 5x minus 14. It's the whole diagonal. And it says that US is 2x plus 10. So that's another diagonal. In a rectangle, diagonals are congruent. So I can say that the length of one diagonal has to be the same as the length of the other diagonal. And I can solve for x. Now I know x equals 8, I can find VT. VT is that piece. That's going to be half of RT. So let's find RT first. 5 times 8 minus 14, it's 26. So this entire diagonal is 26. So half of it is 13. Down here in example 8, JM is x plus 17, and MK is 5x minus 23. Now, because this is a rectangle, not only do the diagonals bisect each other, but the diagonals are congruent. So I can say that each piece of the diagonal is congruent. So I can solve for x. So I'll subtract x from both sides and add 23 to both sides. X equals 10. And now I can find JL. So first I'm going to find JM. 10 plus 17, 27. So this piece here is 27, which means that the entire diagonal JL is 27 times 2, 54. Okay, and we got one more. VW is 9x minus 11. SU, that's this whole thing, is 16x minus 12. So I'm actually going to find an expression for VT. Well, VW is 9x minus 11. So is WT. They have to be the same. So VT is 9x minus 11 plus 9x minus 11. 18x minus 22. And we know that SU, they gave us that, 16x minus 12. Because it's a rectangle, the diagonals have to be congruent. So I can set these two expressions equal to each other and solve for x. So x equals 5. And now I'm going to find WT. WT is 9x minus 11. So that'll be 9 times 5 minus 11. So WT is equal to 34. Okay, we've got some more examples here using properties of rectangles. Okay, I know this is a rectangle. I know that in a rectangle, all 4 of these angles have to be 90. And if it wasn't so messy, I would put every property that I could in the picture. But because there are so many properties, the picture starts to get messy and then confusing. Here, I see a right triangle. Okay, hopefully you see the right triangle also. Okay, so this is Z, this is X, and this is Y. This is 90 from my rectangle. This angle right here is 5x minus 8, and this angle right here is x plus 20. And we know that the 3 angles in a triangle will always sum to 180. So I can add angle x, angle z, and angle y and get 180. And now I can solve for x. X and 5x, 20 minus 8 plus 90, 102. Subtract 102 from both sides. Divide by 6, there's x. And now I can use that to find what I need. One's angle XZW. XZW is this angle here. So what I'm going to do is I'm going to take my 13 and plug it in. 13 plus 20, that's 33. And then I know that this whole angle has to be 90. So if this whole angle is 90 and this piece is 33, then I can do 90 minus 33 to find that missing piece. And 90 minus 33 is 57. So the measure of angle XZW is 57 degrees. Okay, let's look at the example over here. It wants us to solve for x. So I have a rectangle, and I know it's a rectangle because it told me that in the directions on the previous slide. Rectangle, which means that these pieces are all congruent, and that's helpful because now I can see an isosceles triangle. Okay, so I have this isosceles triangle, I know it's isosceles because it has two congruent sides. And here are the base angles. Base angles have to be congruent in an isosceles. So if this is 5x plus 7, so is this one. And I know that this angle over here is 134, but I see a linear pair. These two angles have to add up to 180. 180 minus 134 is 46. So this is 46. And now I can use what I know about the three angles in a triangle. When you add the three angles in a triangle together, you get 180. So this becomes 10x plus 60. Subtract 60 from both sides. Divide by 10. X equals 12. Okay, there we go. Let's look at the next one. We have another coordinate problem. So this one says, tell what you know, or using what you know about a rectangle. Could this be a rectangle? Could these vertices be the coordinates of a rectangle? Well, before you can prove something's a rectangle, you first have to prove it's a parallelogram. Because if it's not a parallelogram, there's no way it's a rectangle. If you can prove it's a parallelogram, then you can move on to prove it's a rectangle. So let's sketch this thing. Do a little mini sketch here. 9, negative 4. So A would be down here. 8, negative 2. 2, negative 5. And 3, negative 7. And if you were using graph paper, it probably looks a lot nicer than this. But I can see that I don't have any vertical or horizontal lines. So counting blocks is not going to be an option here. All right, also when you sketch it, you can also see which sides are opposite each other. So I'm going to find the length of AB and the length of CD. Those had better be congruent. And I'm going to find the length of CB and the length of DA. Those had better be congruent. If they aren't, it's not a parallelogram and I can just stop because it's not going to be a rectangle. So please use the distance formula and find the length of those four sides. Okay, so if you found AB, you found it to have a length of square root 5, and CD is the length of square root 5. So it works out that CD is indeed congruent to AB, so that's good. And for CB, you should have the square root of 45. If you chose to reduce it, that's probably better than what I have here, but I can at least see that DA is the square root of it's also the square root of 45, and so they're congruent. All I care about is that they're congruent. I don't actually care what their length is, just that they're congruent. So my opposite sides are indeed parallel, so this is a parallelogram. Now that I've proven it's a parallelogram, now I have to prove if it's a rectangle or not. So to prove if it's a rectangle, you can find the slopes of each side and prove it has 4 right angles, or you can prove the diagonals are congruent. The easiest, fastest way is to show that the diagonals are congruent. Okay, I wish I had more space. I'm going to go over here. So let's prove it's a rectangle. Rectangles have congruent diagonals. The diagonal in my rectangle here is AC and BD. So now I'm going to use the distance formula again to find the length of AC and BD. So we should be getting really good at the distance formula. Go ahead and find those lengths. Okay, so you should have the length of AC is the square root of 50 and the length of BD is the square root of 50. All that I care about is that they're the same, which they are. So because AC is congruent to BD, okay, the diagonals are now congruent, so this is indeed a rectangle. So I'll write this as a sentence. ABCD is a rectangle because it is a parallelogram with congruent diagonals. All right, so we did the distance formula 6 times. Good job. I know that the distance formula is a little tedious, but none of it is hard. So at least that's the good news. So that was 5.15 and 5.16, parallelograms and rectangles. Today's attendance quiz word is diagonals. In a rectangle, the diagonals are congruent. Please make sure that you spell diagonals correctly. Okay, this is plural, has an S on the end, so make sure you enter it correctly. Capitalization does not matter, but the spelling does, so please make sure you spell it right. If you have any additional questions about anything, please don't hesitate to reach out. I'm happy to help. Have a great day, everybody.